A power IGBT module. The device is a mix between a bipolar and a MOSFET. So it has a collector and emitter like a bipolar, but then a gate like a MOSFET. And essentially it's a bridge driver. So two of the devices are contained inside of this module. And we want to be careful to make sure when testing transistor 1 that everything is hooked up to transistor 1 and not, part way. So first thing I'm going to do is go for the emitter 1 on the device, which is located in two places, but here's emitter 1. Now I'm going to go for gate 1. And gate 1 is right here. We need this guy. And we're going to go for collector 1. Okay, so back to the curve tracer. Of course, when starting out anything, everything goes down low. And basically what we're going to do here is same thing like a transistor. Take the base / gate out, up for thresholds, and then down for breakdown. So it makes sense, right? Down, breakdown. All right. All right, first thing we're going to do is find that threshold, the voltage from a gate to emitter, which is spec'd at 7.5 volts max at 40 milliamps. So I'm going to go try and find like 4 squares, so 10 milliamps times 4 is 40 milliamps, or 40 milliamps divided by 10 milliamps is 4 squares. Now 7.5 volts, I have 10 boxes, so I think I'm going to go for 1 volt per box. I'm switched over to the right, I'm on NPN, and I'm on a nice low supply. There we go. We'll turn it on 1 volt, 2 volt, 3 volt, 4 volt, 5 volts. They're starting to turn on. Now let's count our current. Because really on these things we want to force a current and measure a voltage. So really on any of these things we're trying to get to the specified current, or if there is none, what we the 250 microamps, and then measure the voltage. So 10 milliamps, 20 milliamps, 30, 40 milliamps. So we're at about 1, 2, 3, 4, 5, 6.4, and that's a 7.5 max. Yeah, I think we're almost dead on the typical. The typical was 6. So, all right, so that's pretty good. Now we're gonna turn down. Now we're going to check the collector to emitter breakdown voltage, and like once again, the gate to emitter is like the switch, and the collector to emitter is actually like the power, like your wall switch. You flick the switch and you can control 120 volts manually, and this is the same thing, but it's electrical. So we need 600 volts. Once again, it's always good to start low everything, low. I'm going to go, I need 600 volts, so I got to crank this all the way up to 1500. Red light's on, yellow light's off, we're good. Now, I don't know, at 600, I'm just going to start with 100 volts per division. There's no current, so I like to use 5 boxes, and I never do a breakdown above 250 microamps. They usually will blow up any type of silicon device. So we're going to look for the breakdown at 250. Oh, now I got to see. We got to move the down for breakdown. All right. Now see, this is leaking. That's okay. So when you see, because you're looking for the avalanche now. This device is a 200 amp device, so I guess my rule about 250, kind of goes out the window right there. But
it's a good place to start.
Yeah, it's a good place to start, exactly. So I turned it down, get this envelope smaller, 100, 200, 300, 400, 500, 600. We're pretty good. Now we're hitting 700, and there it is. There's the fuzzy avalanche breakdown. So 1, 2, 3, 4, 5, 6, 7, 8. So, this device can handle, it's about 800 volts. And that's above the 6, so we're good. Now what we're going to do, we got to test the other one.
Yeah, test the second one.
Okay, so, rather than go back to do the gate, the easiest thing to do is to take your module, go and move all of these over. So what we're going to do is we're going to go from gate 1 to gate 2. We're going to go from collector 1, of course we've got to move that to collector 2. Now we got to go from, this was on emitter 1 to emitter 2. Now we're on the second transistor, and we can simply check the breakdown voltage of the second one. 1, 2, 3, 4, 5, 6, 7, 800. They should be the same because they were obviously processed in the same batch. Okay, so still good to turn it down. Remove this and check the threshold of the other device. We'll go up. We're going to turn all this back down. We're looking at for 7.5 volts at 40 milliamps. So back to 1 per horizontal and 10 milliamps per division there. And this will check the other threshold. We got 1 volt, 2 volt, 3, 4, 5 starting to turn on. Now we need to force current and measure voltage. So let's get to the 40 milliamps, 10 milliamps, 20 milliamps, 30 milliamps, 40 milliamps. Now we'll counter voltage. 1, 2, 3, 4, 5, 6.2, 6.4, kind of like the last one. So this module is good. Remove, your stuff. And these little foam pads, the reason they're here is because this is where the gates are, and those are the most sensitive. And emitter is ground. So if you notice, it's gate and emitter, and then gate and emitter. And, so this will ensure that your gates are shorted and you won't blow them up.